All right, so today we're going to talk about protons and neutrons. Tomorrow we'll talk more about neutrons and do isotopes. And then from then on, we're only going to talk about electrons for like the next 2 weeks. All right, so let's start with protons. Some of this stuff will be repeated from yesterday. First thing, mass. You don't usually see the mass of a proton in grams, but I'm going to give it to you today. It's 1.673 times 10 to the minus 24 grams. Everybody can tell that's a small number, right? We know they're found in the nucleus. Number of protons equals atomic number. So again, that's the number in the top left-hand corner on the periodic table. So if I say, hydrogen's atoms have 1 proton in the nucleus. Helium atoms have 2 protons in the nucleus. Aluminum atoms have 13 protons in the nucleus, right? So it is the number of protons that determines which element it is. That's the definition of the element, basically. So if it's a certain number of protons, it has to be that element. And what's left? Charge. Charge is positive. It's +1, so we're at +1 for it. And that'll matter when we start talking about ions later on. So that's it for protons. And then neutrons. And what do we got? So I give you the mass of the protons and the neutrons to the 4th significant figure because I want you to see that they're not exactly the same. Thank you. So neutrons are actually 1.675 times 10 to the minus 24. They are slightly more massive than protons, which after today you're probably never going to need to know that. But I figured it was interesting, so I put it in there. Found in the nucleus. Number of neutrons. So again, this is atomic mass minus atomic number. So in atomic mass units, which is what we use on the periodic table, a proton has a mass of 1 and a neutron has a mass of 1. You made up the mass that would be exactly equal to roughly equal to the proton and neutron. So whenever you see the atomic mass under the symbol, that's the sum of the protons and neutrons. But then if you look on the periodic table, you'll see something like boron, for example, is 10.8. All right, so boron, what you see on the periodic table is there's a 5 for the atomic number, and then you see 10.81. So you say to yourself, well, how does that make sense? Because if you have 6 neutrons, then it should be 5 plus 6 is 11. Or if you had 5 neutrons, then 5 plus 5 would be 10, right? So why do we have 10.8? Well, this number, these masses on the periodic table, are actually a weighted average. So that means some borons have 6 neutrons, so their mass is 11, and some have 5, so their mass is 10. So the average of the masses is 10.8. So that's how you get this number. When I ask you to find number of neutrons, for now, what I want you to do is just round it. So if it's 10.8, round to 11. So if I said how many neutrons in a boron atom, just round to 11 minus 5 is 6. So that's all. Later on, we'll talk more about that tomorrow. We'll talk about isotopes. And then saying, well, yeah, we're kind of that. What's left? Okay, last thing, charge. Charge of a neutron is 0. All right, so that's it for that. So for today's worksheet, mostly, I want you to know this stuff, but mostly what I want you to do is find number of protons, find number of neutrons. I want to just go over and do all that. So let's do a couple more elements. So, I don't know, pick one. Favorite element.
Neon.
Neon, okay. So neon, what's the atomic number? 10. I do. I ask students so they can participate, so they look at the periodic table. It's part of teaching. I know what the atomic numbers. What is the mass? I should like snap my fingers. What is it? 20. Okay, so number of protons. 10 protons. Right? Protons is just this number. You just look at the number. Neutrons?
10.
That's also 10. It's 20 minus 10, right? 20 minus 10. So 10 neutrons. All right. Let's do sodium. What's the atomic number of sodium? 11. What's the mass? 22.99.
So you just round up to 23.
That's what we're going to do. So, number of protons is 11. And then to find the neutrons, yeah, we round this to 23. You better never round this to 22. If I see somebody round 22.99 to 22, I swear not only will I fail you, I will have you thrown out of my class. I saw somebody do that one time. 22.99 and rounded to 22. You believe that?
This low.
That's like if something's 99 cents, you're like, oh, it's free because it rounds down to 0. Anyway, 12 neutrons, right? Unbelievable. You guys are all right.
That's why we your favorites.
Maybe. Let's do one more. Let's do a high number. Pick something near the bottom of the graph.
What about
Radon.
Radon. That's Rn.
Yeah.
Number 86, I think.
Yeah.
All right, let's get this out of the way.
what is your radon? It's number 86.
All right, what's the mass?
220.
What's after that?
Nothing. It's in parentheses.
Oh, yeah, okay, that's fine. It's because it's radioactive, that happens. Okay, so how many protons? 86, right? And then to find neutrons, it's going to be 222 minus 86. So what's that come out to?
Take away.
146.
146? 46. Trust me. Actually, you just lied to me. So I think it's 136. Thank you. 136 neutrons. And so you'll notice this with the bigger numbers, they tend to have a lot more neutrons than protons. Usually the first 20 elements on the periodic table, they tend to be about a 1-to-1 ratio. With the bigger numbers, when you get into 80 or 90, you see about 1.5 times as many neutrons as protons. All right, questions on any of this? All right, we are done. On the worksheet today, only do up to number 19 and then do the table on the back. Don't do 20 through 25.